Good morning, good evening, good afternoon. My name is Deva Ferzofala Raju with NPM of 20065179115. I would like to present some paper that I have resumed and summarized. The title is Investigation of Signal Conditioning for Tx-RxPEC Probe at High Lift of Using a Modified Maxwell's Bridge. So this is a final presentation. Okay, so this is a table of contents. The first one is being the introduction, the second one is the objectives, and the third one is discussion, and the fourth one results, and the fifth one is conclusion or analysis. So basically, the signal conditioning and Maxwell Bridge 101. So the purpose of Maxwell Bridge is basically in order to calculate an unknown inductance in AC circuit, Maxwell bridge is utilized, and the structure is an adaptation of Whetstone bridge, as we know, and it contains assortment of resistors, capacitors, and inductors. And the second one is signals conditioning. What is it? Is basically modifies the raw analog output signals and regenerated by sensors and provides necessary circuitry between the sensor and data acquisitions. So this modification transforms these diverse signals into signals compatible with process monitoring and also control devices. So why does it modify? Why does it need to be modified? So basically, why does it need to be modified? Because the bridge circuits are typically used to convert the impedance change or magnetic field change into an electrical signal. In order to counteract the influence of coil and improve the sensitivity, to cancel the offset caused by the self-impedance changes the balance is as disturbed. The AC bridge circuit is operating in balance mode. For this purpose, the conventional AC bridges such as Maxwell's inductance bridge, Anderson bridge, Hayes bridge, and etc. Are utilized. However, bridge circuits have a limited linear input-output characteristic range. The measurement error caused by stray capacitance between the bridge node and ground and stray inductance of the inductive coils is another disadvantage of the conventional bridge. In order to eliminate the influence of self-impedance of the RX coil, which means the receiver, reduce measurement error and improve signal noise to ratio and linear input-output characteristics, it is necessary to modify the Maxwell's bridge. So after we know the objectives and the goals, why does it need to be modified? We go to the comparison between the Maxwell inductive bridge and the modified one. So in the figure 2, different signal conditioning circuits. So basically, this paper aimed at the high lift of inspection are susceptible to noise. Therefore, we propose a signal conditioning technique that can enhance the signal noise to ratio by eliminating the offset caused by the self-impedance of the receiver. As you can see here, the dominance of the output signal modify Maxwell's inductive bridge with an op-amp circuit, and to remove the RX in order to improve the signal ratio linearity range at high lift off is how to propose signal conditioning circuit is constructed. And then consequently, this section describes the circuit's modification operation. The inductance bridge of figure 2A is modified by 3 high impedance, as you can see here, and low noise operational amplifier and passive components as shown in figure 2B, which is here, and bridge form the feedback loops of 2 inverting op amps A1 and A2 respectively, and the voltage is applied to the TX, which is coupled to 2 receivers. The output of A1 and A2 is then fed into the subtractor OM A3, which is right here, and whose output is measured in volts. So moving on, was there any errors? Of course there's an error, because the output of the proposed circuit will contain errors caused by the non-ideal characteristics of an actual devices, because we use actual devices in here. Next, errors can caused by these non-ideal device components and other factors are analyzed. The first one is offset voltage, which will have a finite input offset voltage. The second one, the resistance, this imperfection generate output offset that can alter the response signal. When implementing the proposed circuit, matching resistance should be selected to minimize this error. The third one is electromagnetic interference. Of course, one of the sources of error in proposed circuit is the electromagnetic interference on the inductive coils. This thermal setup should be shielded from electromagnetic interference to reduce this error. So, was it effective? Of course, is it effective? Due to the influence of the crack, the two circuits exhibit different response shape as Tx passes over the crack. The module circuit's response peak, whereas the response of Maxwell bridge from a through negative peak. The Tx call detects the crack between 10 and 30 am. So for Maxwell's inductance break, it's changed from 0 millivoltage to 27 millivoltage for the modified circuits when sensitivity in amplitude change is considered. As you can see here, it's very smooth, not like the non-modified bridge circuit. So the conclusion is it better? It is better. So basically, the modified circuit measures accurately. The circuit is simpler, cheaper, and no bridge balancing is needed. And the large impedance change can be measured and applied by the signal conditioning circuit as the receiver self-impedance has been suppressed. Small linearity range of conventional Maxwell bridge is improved. So therefore, thank you very much for watching, and that is the basic main points of the investigation of modified Maxwell bridge for the signal conditioning. Thank you very much. Bye bye.